Hello everyone, welcome to my channel. My name is Deepak Nirola and in this Python tutorial series, I'll be talking about different topics in Python that we have to use in our daily programming job. Last time I talked about higher order functions like map, reduce and filter, and I also discussed about how to create our own higher order function with hands-on example. For today, I have chosen two topics, closures and decorators. They are very useful and related topics. So let's start with the closure. A closure in Python is a function object that remembers the value of variable from its enclosing scope, even when the outer function has finished executing. It can capture the values from its surrounding scope. We can define a function inside another function as seen in this example, and the outer function should be returning the inner function. This is the way of writing the closure. The closure can capture the value from its surrounding scope, that is the inner function can capture the values from its surrounding scope even when the execution of the outer function has finished. A closure can capture the values are available alive to this closure. So let's see it from the example. I'm creating a new Python file. I'm creating a simple example that will implement y equals to m into x plus c, a linear equation. You already know that y equals to mx plus c is a linear equation, and our closure will be implementing this formula. So let's make outer function. You can name your function whatever you want. This outer function will take m as an argument. M means slope. It has also another member variable x. I'll put 7 here. So in this function there are two local variables m and x. Outer function will get m from its calling, and x is its hard-coded value. We define nested function named inner function. You can also name this inner function whatever you want. In my case I am using inner function. So it will take c as an argument. So what this inner function do? It will return m into x plus c. Simple. The last thing to remember is this outer function must return the inner function. So return inner function. Okay, so this is our closure. This is the implementation of a closure. We have nested function. The outer function will return inner function. So what is unique here is the inner function is capable of using the value of outer function even when the outer function execution is finished. This is the uniqueness of the closure. So let's see it in example. If underscore name equals to underscore main. For every Python script we do this so that the code becomes a script. And here let's first call our outer function. If we call our outer function with this argument, then it will return inner function. So I am writing closure as a variable name. You can name whatever you want and call outer function. To call outer function we need to pass this argument. So I am currently passing 7, not 7, I will pass 3 as an argument. Okay, so the value of m will be 3, the value of x is already 7, and when we call it, it executes and returns the inner function, then the execution stops. So here outer function execution is started, and when it returns some value, then started and finished in this line. So in closure there is inner function. Since outer function returns inner function, this inner function is assigned to this closure. So I am creating new variable y which will store the value returned by this closure function. So we are calling this closure function. If we call this closure function, this is actually inner function. You can also see in this hint that the def closure is getting argument c. So here is c. We can pass any number. I am passing 2, and what it will do is it will take c as an argument, and it will do m into x plus c. So m means 3, x means 7, plus 2 means 23 as an answer. So output should be 23. If we print y, output should be 23. So to call our function, I can run it from here. You can see that 23 is our answer. So what is the unique behavior here? You can see that we called outer function, and here outer function returned inner function. So execution started and finished here. And when we call closure, the closure is capable of capturing this m and x from its surrounding scope, from its enclosing scope. Even when the outer function execution is finished, m and x variables are alive. They are not destroyed. But in normal case, they should be destroyed. Since we are implementing closure, these variables are available. When we call our closure function, then it gets m and x in its own scope from its surrounding. So that's the unique nature of closure. So to create closure, we have an outer function, we should have inner function. The function name can be whatever, but the outer function should return the inner function. This is the closure. So calling outer function returns inner function. If we call inner function and pass argument to inner function, it can also be it is able to capture the values from its outer function. So this is the uniqueness of the closure. Closures are powerful constructs in Python that enable advanced programming techniques such as function factories. We can create functions from another function. It can be used as decorator. We will discuss about this topic later. Memoization and caching, event handlers, etc. The closure captures the variable from the surrounding scope and keep them alive even when the outer function has finished executing. I have already shown you about this. There are some applications of closure. Data privacy and encapsulation. Since one function is encapsulated inside another function, it is useful in data privacy and encapsulation. Memoization and caching. Since the since the surrounding values are alive, we can use them as a caching, and we can also use them as a decorator. So decorator is our next topic. I will discuss decorator in the next topic. So decorator in Python is a special construct that allows you to modify or enhance the behavior of a function or class by wrapping it with another function. Decorators are denoted by @ symbol followed by the decorator function or class. In this example, time profiler is a decorator function. Our getSquare is another function that is decorated by our time profiler decorator. So when we call our decorator function, then the when we call our getSquare function, then this decorator function gets executed, and this getSquare function name will be passed to this time profiler instead of directly calling this. So the control is passed to this time profiler decorator. So the function it takes is this getSquare. The arguments and keyword arguments catches everything that is required for this function. Currently it is item list, and the result is returned here. Since this getSquare function is returning some result, we have to return that result also. And the noticeable thing here is the outer function must return the inner function. This is the way of creating the decorator, which is similar to closure, but decorator function takes function as an argument. So let's see it in action from the example. Okay, so in this example, let's first define our normal function get square. Get square takes item list as an argument, and it will define a new item list first, which is empty list. It will iterate over this item list. For item in item list, it will append item into item. This is the square of the item. So square of each items are appended to this new list. After calculating the square and appending the result, the new list will be returned, new item list. Okay, so it will be returned. So if we call it to, before calling, let's define the input list. Input list equals to you can define whatever you want. I'm currently defining 5 items in a list, and I will call this get square function. Result equals to get square function, and we have to pass that input list, and we can print that result. So this is the simple function call. We have a function which takes list as an argument and creates a new list of square of its items. So let's call it. You can see that 4, 16, 36, 64 and 81 are printed. 2 square is 4. A square of all items are calculated and returned. So this is a simple example. So how can we change the behavior of this get square function without touching its source code? So to change the behavior of this function, we can create a decorator. So to create a decorator, first of all, I will create a simple decorator function. I'll name outer function same as closure, because the syntax of closure and decorators are way of creating the closure and decorators are same. So outer function, but outer function will always take function as an argument. And then we can also define our inner function. Inner function can take anything, any items. To catch everything, we can use args and quirks. Okay, so if you know what the function takes, you can define that. Like you can define num list here, since it is accepting the list. We can name that variable anything, but we have to know that this is this. Okay, so but to catch everything, we can define args and quirks. Okay, so it will catch everything. And after that, we can call that past function. Okay, this past function can be called here, and to call them, we have to pass the arguments required by that function. So all arguments are presented here, so we have to pass them. And if this function returns something, we have to assign it to a variable, and after that I will return that r. Okay, so another thing we have to know is we have to return this inner function from outer function, same as closure. So this is closure, and this is also a decorator. This is also closure, this is also decorator. But how is it decorator? The decorator function takes another function as an argument, which is possible in Python. So let's decorate this function. Now our get square function is decorated by this function. Okay, so if we print fnc here and run our program, you can see that function get square at 80, and the result is printed successfully. So what happened here? When we call our get square function, this function should be called, but this function is not called directly here. The control is passed to this outer function, decorator function, and this print statement is executed. That means when we call our get square function, this function is not directly called, but this is called through this decorator. This is called in this line because get square is passed as a FUNC here, and this FUNC is called here with the arguments that is captured, and the result is returned here. So this function is being called by this decorator. So we have control in here. So since we have control here, we can change the behavior of this function. So instead of let me change the output. I can print output here to prove you we got access to the output. You can see that this is printed from here, and we can change the behavior by like let's append r.append. Since r is a list, we can append something here. I will append this value. Okay, so you can see that the output is 4, 16, 36, 64, 81, and this value. So this value is appended here. So we can change this get square behavior like this. Okay, we can also intercept the arguments. You can see that if I print args, there is this item. So this is actually a tuple, and it is the first argument. And if I print 0 index argument, you can see that 2, 4, 6, 8, 9 are present, and I can append something there. Okay, so how to intercept the input? Args 0, args 0 index is this list, and I can append value like I can append 3. Okay, so I have appended 3 to this list. Then what is the output? You can see that 4, 16, 36, 64, 81 are previous values. 9 is added since square of 3 is 9, and another item is added from this line. So from this example, you can see that the behavior of this function can be changed by this decorator without touching the source code of this function. So this is the advantage of decorator. So decorator can be used in various applications like logging. We can log our application from a single decorator. We can decorate everything. We can also use decorator in authentication and authorization. Like suppose this is our controller function that need to be accessed from the authorized user only. So where do we check authentication? If the user is authenticated or not, we can use decorator function and decorate this controller. Okay, so this is the advantage. So in this example, I have used the decorator to calculate the to decorate this get square function. So let's make one use from here. I don't want to change the behavior of the function, but I want to measure the time of execution that it takes to run. So to do this, I have to import time. So before running this function, I can measure the epoch time. T1 equals to time.time. It will get the epoch time. I will also measure the epoch time after the execution of this function finished, and after that I will print T2 minus T1 seconds. Okay, so now when this func is executed, this func means this get square function, then after this function execution is finished, then time is measured. Now let's run our program. You can see that 3 output is printed. So first is the function name, printed from here. Second is the execution time, printed from here. And the third is our result, which is printed from here. So when we call our get square function, then the execution of this get square function is not from here but from this decorator. Since we have already decorated this get square function, outer function decorator will get that function name, prints it, then the inner function gets called. The inner function takes the epoch time as t1, then runs the function passed to it with the required arguments captured from this get square, and the t2 is measured. So t2 minus t1 gives the time of execution in seconds. So we have to return this result also, since this is a returning type function. So after that, this is printed and the result is printed. We can also parameterize our outer function. So to parameterize it, we have to make another function here. You can name whatever you want, and this function will take func, but this will not take func. This will take something that we want to send from here. So for now I am naming the variable as count, and we can print count here. We have to push this function ahead, and also from this outer function we have to return this wrapper. Okay, you can name your function whatever you want. So now when you decorate this get square function with this outer function, you have to, or you can pass the argument like I have passed 5. So let's add some symbol in this print statement and run the program. You can see that 5 is printed here. You can also print this inside it, because this is available inside this function and also inside this function due to the behavior of closure. So you can see that it is already printed. So in this way you can parameterize your decorator function. You can also pass multiple arguments like count. I can also pass another argument, but you have to pass it from here. Like if I pass Deepak and print name here, you can get that name. Okay, so let's run it. You can see that 5 is printed, Deepak is printed. In this way you can parameterize your decorator function. Decorator function are very useful in Python. You can use it in various types of application like logging, authentication and authorization, caching and memoization, rate limiting, validation and input serialization, performance monitoring and profiling. Like we have implemented this performance monitoring like things here. This decorator will this decorator will measure the time of execution of this function. So if you have any question related to decorators and closures in Python, please comment below. I'll be happy to answer you in that comment. So thanks for now. Let's see in another video. Thank you.